So in this section, we're going to be dealing with validation and error handling, and therefore it's good that you familiarize yourselves with NestJS pipes. So NestJS pipes. Pipes operate on the arguments to be processed by the route handler just before the handler is called. Pipes can perform data transformation or data validation. Pipes can return data either original or modified, which will be passed on to the route handler. Pipes can throw exceptions. Exceptions thrown in pipes will be handled by NestJS and then parsed into an error response. And pipes can be asynchronous. Default pipes in NestJS. So NestJS ships with some very useful pipes within the NestJS/common module. Here's an example, validation pipe. It validates the compatibility of an entire object against a class, which goes well with DTOs, or data transfer objects. If any property cannot be mapped properly, validation will fail. This is a very common use case, therefore having a built-in validation pipe is very, very useful. The parseInt pipe, for example, ensures that certain arguments are integers. So by default, arguments are of type string. Even if you pass a number, it's going to be a string. This pipe validates that an argument is a number, and if it is, it's actually going to transform it into an actual JavaScript number type. So it saves you some time and also validates for you. Custom pipe implementation. So pipes are classes annotated with the injectable decorator. Pipes must implement the pipe transform generic interface. Therefore, every pipe must have a transform method, and this method will be called by NestJS to process the arguments. The transfer method accepts two parameters. One is the value, which is the value of the processed argument, and the second one is metadata, which is optional. This is an object containing metadata about the argument. Whatever is returned from the transfer method will be passed on to the route handler. Exceptions will be sent back to the client after being handled by NestJS. And pipes can be consumed in different ways. These are handler level pipes, and they are defined at the handler level via the usePipes decorator. Such pipe will process all parameters for the incoming requests. Parameter level pipes are defined at the parameter level. Only the specific parameter for which the pipe has been specified will be processed. Global pipes are defined at the application level and will be applied to incoming requests regardless of where they sit. So, parameter level versus handler level pipes, which one should you choose? The answer is it depends. Parameter level pipes tend to be slimmer and cleaner, however, they often result in extra code added to handlers. This can get messy and hard to maintain. Handler level pipes require some more code, but provide some great benefits. Such pipes do not require extra code at the parameter level. They're easier to maintain and expand, so if the shape of the data changes, it is easy to make the necessary changes within the pipe only. The responsibility of identifying the arguments to process is shifted to one central file, that is the pipe file. And it promotes the usage of DTOs, which is a very good practice, as we've seen earlier. So here's an example. We have an HTTP request post to /tasks coming in. The handler is identified. The pipe validates the arguments. If successfully validated, the handler is then called, then returning the HTTP response back to the client after handling the function. If we fail to validate the pipe, we can throw a bad request exception, which then results in a 400 response, an error response to the client. There you go. You know enough about pipes. Let's actually start using them. Currently, we have no validation for when creating a task, and that means that tasks can be created with empty titles and descriptions. So let me demonstrate. When we create a task, we could say no value here and no value here and hit send. And as you can see, we get a 201 created response and the task is created with empty values, which is pretty bad. So let's fix that. I want to open up my create task DTO file, and this is the DTO that I use for creating a task. And we're very lucky because DTOs in NestJS allows us to easily implement validation at this level. In order to utilize validation and transformation pipes, we need to install two packages. So let's open up our terminal and type in yarn add. And then the first package is class-validator. The second package is class-transformer. And let's hit enter. All right, so these are installed. I'm just going to start the application in development mode and minimize my terminal. Let's take a look at the class validator GitHub page. Really great package. It provides us with a huge amount of decorators that we can use in our classes to define our validation rules. Let's take a look at some of the pipes that are the decorators that are available for us from this package. There should be a table down here. There you go. So a huge amount of decorators with a description of what they do. Feel free to search for that. That's class validator on GitHub. I will include a link in the resources for this lecture. And basically, you have a bunch of them. And the one that we're interested in, at least in this case, of the title and description is not empty. Checks if given value is not empty. So let's use that. Back to our code. Here in the DTO file, I'm going to import is not empty from class validator. And now to use this, all I have to do is decorate the fields that I want to use this decorator against. Is not empty and is not empty. And there you go. You just got yourself validation. It will also handle the errors for you and present them nicely to the user. That's really, really great. Okay, so we do miss one thing, which is telling NestJS to actually use the validation pipe. Now, as you saw earlier in the slides, we could do that using different methods, such as at the controller level or the parameter level, but I'm actually going to do this at the application level. So I'm going to basically tell NestJS, whenever you encounter a validation decorator, I want you to run your validation pipe. So I don't have to explicitly define it in any controller or in any parameter. So what I'm going to do here, just before listening and basically making my server live, I'm going to say app.useGlobalPipes, and I'm going to say new validation pipe, and I'm going to automatically import validation pipe. And there you go. Don't forget the parentheses here. And now what's going to happen is that whenever NestJS encounters any of those validation decorators, it will know to execute validation pipe. Save us from a lot of code at the controller level. That is all we need. Everything seems green here, and now we can test it. So heading over to Postman, let's try to run the same thing earlier, call the same endpoint without a title and a description. And what we get here is an error, a 400 beta request error, and we get them nice messages as well. So all this was done for us and probably saved us quite some time. Now, just to test that it works when we do provide those values, let's say cook dinner, include lots of vegetables. There you go. The task has been created and we successfully implemented a validation for title and description. I want to implement some error handling for when we try to get a task that does not exist. I'm going to start by heading over to the service. Here we have our getTaskById method. So currently what happens is if the task does not exist, let's actually try it out. Head over to Postman, getTaskById, send. We get a 200, but the response is empty. So this is obviously not what we want to have. So essentially what we want to do here is say, try to get task. If not found, throw an error. That would be a 404 not found error. That's just the standard. Otherwise, return the found task. So let's turn this into code. We already have the try to get task part, which is this. We're just going to say const found equals this. So if this one has a value, or if it's truthy, I should say, then that means we found our task. If not, we need to throw a 404. So if not found, do something. Otherwise, return found. What do we do here to return a 404? Well, luckily NestJS makes it incredibly easy for us. All we have to do is the following. Throw new not found exception. Notice the automatic import there. And there you go. And what is going to happen here is that this throws an exception, or rather an object of the not found exception class, and that then bubbles up into the internals of NestJS. And that is handled there. So of course, if you were to wrap this with a try-catch block, you would have the opportunity to handle this yourself. But when it gets to the internals of NestJS, it will map it, it will recognize it first, and then map it into the appropriate HTTP response code, which is 404 in this case. Likewise, there are many other exceptions that you can throw. And we'll be doing that later on in the course as well. So, by the way, if we throw something or something throws for whatever reason, I don't know, we try to interact with the database and that's not successful, an error will be thrown, and then NestJS will not be able to map it into a HTTP response code because it just does not recognize it. It will then be mapped into a 500, which is the internal server error. So that is really, really cool. Let's quickly test it. By the way, notice that we didn't have to change anything in our controller. And this shows you why we're using services at all. We only change our business logic. And that does not even affect our controller. So again, what happens is that this throws, which then bubbles up to the controller, which is unhandled at the controller level, right? We don't try or catch anything here. So it then goes to the internal of NestJS, and then it's handled. Let's try it out. Get a task by ID. I know this one does not exist. And there you go. 404 not found with a nice error message. By the way, you can also customize the error message. So right here, you could provide an optional argument and say, task with ID not found. And let's try it again. I do have my server running, by the way. It's right here. There you go. Nice formatted error. So this is super, super simple, right? Another thing I want to mention is reusability. So remember here at getTaskById, we throw a not found exception when we don't find the task. But we do have another method that uses getTaskById, the update task status method. So what happens here is that if we try to update the status of a task that is not found, it is going to do the work for us and throw that. Let's try it out. Update task status. There you go, not found. Okay, so that part is done. All right, next I want to handle the case where we delete a non-existing task. And this is going to be super, super simple. Again, thanks to this abstraction that we have with services and controllers, we don't have to change anything in our controller. How great is that? So really similar to this, we're just going to take advantage of this method, getTaskById, and that is going to handle the error handling for us, throwing that not found exception. What I'm going to do here is say const found equals this.getTaskById with ID, and this will already work because it will throw an error. We do get a bit of a complaint here because we have an unused variable. We could use it and then basically say found.id, and then it's used. And again, this is not the best option because then you loop once to get the task by ID and then you loop again to filter. But again, this is just for demonstration. One more time, we're going to be using type-OR in the future to achieve this. Let's quickly test this. Delete a task by ID. There you go. Task does not exist. And this feature is done. Let's continue. The last thing we need to improve in terms of validation is our update task method. Currently, we can provide any value for the status of a task. And of course, we only want to allow certain values. The values defined in our model, those three. I think the simplest way to do it, among so many ways to do it, some of the ways would be creating a custom pipe, defining a pipe at the parameter level, and so on. I think the simplest way would just be to create a new DTO and then define the validation rules using decorators in the DTO. So yes, it is going to be a whole DTO for a single status property, but it is still going to be cleaner than defining a whole custom decorators. Plus, we don't have to keep maintaining this decorator and we don't have to test it since class validator is already well tested for us. And this is the kind of stuff you always have to think about when developing applications. You have to think about scalability and maintainability. So let's do that. Let's create our new DTO. And I'm going to call it update task status.dto.ts. I'm going to export a new class update task status. I'm going to define my status property here, which is of type task status that I've automatically imported. Now there is one really useful decorator for me to use, which is enum, also automatically imported. And here I can simply provide the entire enumeration, and then class validator in NestJS will validate that the status property is at least one of those values. Very, very simple, right? So now that we have that, we need to make some changes in our controller. Rather than extracting the status from the body directly, we're going to be using the entire body decorator and then change the parameter name to update task status DTO of type update task status DTO. And now we have two options. Either pass the entire DTO here to the service method, and that also means we need to make a change here, or simply destructure it here in the controller and then pass the status directly. Because at this point, we have a guarantee that the validation has been successful. So it doesn't really matter which way we go. I have no preference, so I'm going to flip a coin. And I just flipped a coin, and the coin said we should destructure it here and then just pass the raw status to the service. So let's do that. There you go. Let's make sure everything is green. Looks good. And now we can test it. So first, let's create a task, copy the ID of that task, and then update task status. First of all, we know in progress is a valid status. Let's just try to do that first. There you go, successful. And let's try to do something like I am not valid. And there you go, 400 better request. Status must be a valid enum value. That's it. We are done. That was quite simple, right? All right, so here is a small challenge for you. Currently, our search/filter functionality does not validate anything at all, and we could add two validation rules. First, we could make sure that the task status is a valid status. Secondly, we could ensure that the search term is not empty. I want you to try and do this. Take a look at the class validator documentation and feel free to kind of peek into the previous validations that we have done. I'm going to show you my solution in a few seconds, so please pause the video if you want to give it a shot. All right, we're going to add those rules in the DTO that we already have for getTasksFilter. So we have status and we have search. The first thing I'm noticing is that we're using the TypeScript sort of optional question mark thingy. That is not going to work at runtime because, well, TypeScript does not exist at runtime. So we want to make sure these two fields from a validation point of view are optional. And the way we can do this is by using the isOptional decorator. I'm going to use it on both of them. Now, if a value is provided, we do want to apply some rules. For status, the rule is going to be the same as we've done earlier. We're going to use isEnum to check that it's in the enumeration and SQs, and then use task status. Here in search, we just want to make sure it's a string. So we can say isString. There you go. I think we're done and we can test it. So get all tasks. We don't have any tasks at the moment, but that's fine. If we do this, we get everything. That means the optional part is working. Just to show you an example, if we remove those, we then get some errors. So we do want them to be optional. So then we bring isOptional back. Now, status equals hello. Obviously, that's not a valid status. We're going to get an error for that. You could change it to open, which is a valid status, and then it works. And then for search, we can say room or whatever it is, book with a lowercase c. I don't have any tasks, so I'm not going to see anything, of course. But anyway, this just works as expected. So I hope it went well for you. And remember, as always, feel free to share your struggles in the Q&A section and I will help you.